I got it right. This isn't so hard after all.
See, Casey? The motherboard is the most important part of the machine.
Sofsource has products that enhance learning, simplify complex decisions, and entertain, all at an affordable price. Sofsource is committed to providing you learning tools to achieve your goals at home, at school, and at work. Inside each Sofsource package, you'll find a registration card. Please take a moment to complete the information and send it to us. Or if you'd rather, you can connect to our website using your browser and modem and simply register online. The CD you are using now is only the beginning of the resources you can use as a Sofsource customer. Fast and reliable, our website is available 24 hours a day, 7 days a week. As a Sofsource customer, you can even get discounts and earn valuable merchandise. We love to hear from you, so write, call, or email. Sofsource, your first choice for learning tools that work.
Welcome to Algebra 1. In Chapter 1, we'll review the operations on positive fractions, decimal and percent forms of fractions, and the order of operations. We will also work with variables, algebraic expressions, and equations. Welcome to Algebra 1. In Chapter 1, we're working with equations, and we're given this equation 4x squared minus 2 equals 34. In this problem, we're asked, is the number 3 a solution to this equation? To work this problem, we should substitute 3 in for x and see if we get a true sentence. The original equation, 4x squared minus 2 equals 34, has only one x in it. So if I substitute 3 in right there and then simplify, 3 to the second power is 9, 4 times 9 is 36, and 36 minus 2 does equal 34. So the answer would be yes, 3 is a solution to that equation. Operations on signed numbers and properties of number systems are developed in Chapter 2. We will also look at simplifying algebraic expressions. In this problem, we're supposed to clear parentheses and combine like terms. We're given the expression minus 3 times parentheses 2y minus 3 minus parentheses 7 minus y plus 3y minus 7. And we're supposed to simplify that expression by clearing parentheses and combining like terms. To clear parentheses, we use the distributive property. We need to distribute this minus 3 through the first parentheses. Minus 3 times 2y would be minus 6y. Minus 3 times minus 3 would be plus 9. We also have to distribute this minus 1 through that parentheses and get minus 7 plus y. No parentheses for the last two terms, so they're just brought down. The next step is to gather the like terms. Minus 6y plus 3y are all like terms, and the terms without letters are also like terms, 9 and minus 7 and minus 7. Combining those, adding them up, we get minus 2y minus 5. So the original expression simplifies to minus 2y minus 5. Techniques for solving equations are presented in Chapter 3. We will also solve inequalities and ratio and proportion problems. In this word problem, we're given that Bill had $12 more than Jeff. Also, Jeff had 15 less than Mark. If they had a total of $75 altogether, how much did Jeff have? A good way to work this problem is to let x be the amount of money that Jeff has. That's the amount we're trying to solve for. Based on the given information, Bill has 12 more than Jeff, and so we can represent that by x plus 12. Mark has 15 more than Jeff, so we can represent that by x plus 15. Adding up these three amounts, the total is given to be 75. We can then remove parentheses and combine like terms. X plus x plus x, 12 plus 15. That combines to give you 3x plus 27 equals 75. Subtracting 27 from both sides, we have 3x equals 48. And finally, dividing by 3, x comes out to equal $16. So that's how much money Jeff has. X equals $16. In Chapter 4, we will study the rules for exponents and the definitions of polynomials. We'll also develop the techniques for adding, subtracting, multiplying, and dividing polynomials. In this chapter, we're working with the four operations on polynomials. We've chosen a division problem. We're to divide x minus 2 into the polynomial x squared minus 3x plus 7. We are to divide x minus 2 into x squared minus 3x plus 7. The procedure in dividing polynomials is to take one term at a time. We're supposed to take this first term and divide it into that first term. X divided into x squared goes x times. So I put the x over the x column. The second step is to multiply the x times both of these terms. X times x is x squared. X times minus 2 would be minus 2x. That completes the multiplication step. The third step is to subtract. In order to subtract, you have to change the signs and treat it as addition. This would change to a minus. Under addition, that cancels out. This changes to a plus. Adding that to minus 3 gives me minus 1x. That completes the three steps. So then you bring down the next term and start that cycle all over again. X divided into minus x goes minus 1 times, and then the multiplication. Minus 1 times these two terms gives you minus x plus 2, and then the subtraction. Change the signs and treat it as addition. This becomes a plus and cancels out. This becomes a minus, combines with a 7, and you get a remainder of 5. So the answer would be x minus 1 plus the remainder 5 over the divisor x minus 2. In the material in Chapter 5, we will learn how to graph linear equations and find the slope of a line. Then we will look at the different forms of a linear equation and also graphing inequalities. In this chapter, we're working with equations and inequalities. We selected an inequality, 3x plus 4y is less than or equal to 12. And the problem is to graph the solution set for this linear inequality. The first step in drawing the graph of the solution set for an inequality is to change the inequality to an equation. So I'm going to replace less than or equal to with equals. That gives me the equation 3x plus 4y equals 12. Drawing a graph of this line will give me the boundary for the solution set. To get a graph, I can find the intercepts. When x is 0, this term drops out. Dividing by 4, y is going to equal 3. Also, when y is 0, this term drops out. Dividing by 3, x is going to equal 4. Plotting these 2 points, 0, 3 would be here, and 4, 0 would be here. Then you draw a line through those 2 points. We drew a solid line because this is a less than or equal to. If that had been strictly less than, then I would have drawn a dotted line. But in this case, it's a solid line. We know now that the solution set is either on this side of the line or on this side of the line, one or the other sides. And we just have to try an arbitrary point, and the origin is convenient, 0, 0. If I put 0 in for x and 0 in for y, that adds up to 0 on this side, and 0 less than or equal to 12 is a true sentence. So we've identified that 0 is a solution. Well, that's the same side all the solutions are on. So I would shade in that same side that the origin is on. This would be a picture of all of the ordered pairs that are solutions to this inequality. In Chapter 6, we will develop factoring techniques. Then we will use these factoring techniques to solve quadratic equations. In this problem, we're given a rectangular cement patio. we're given that it is 8 yards longer than it is wide. We're also given that the area is 20 square yards. The problem is to find the length of the patio. The basic formula that we're working with in this problem is that area equals length times width. If we let x represent the width, we're given that the length is 8 yards longer than that, so we can represent the length by x plus 8. Multiplying these two together, we have the area, which is 20. Clearing the parentheses, x squared plus 8x, and bringing the 20 over, minus 20 would equal 0. This is a quadratic equation. We can solve this by factoring. X times x is x squared, 2 times 10 is 20, and if you check the middle term, 10x minus 2x is 8x, so it checks out. So we can set each one of these factors equal to 0. If you set x minus 2 equal to 0 and move the 2 over, you get x equals 2. Setting x plus 10 equal to 0, moving the 10 over, you get x equals minus 10. The minus 10 has no meaning in this problem since we're talking about distance, so we can rule that one out. That means that x equals 2. So the length then will be 2 plus 8, or 10. So the length of the patio is 10 yards. The addition, subtraction, multiplication, and division operations on rational expressions are covered in Chapter 7. We will also solve equations that have rational expressions present. In this chapter, we're looking at rational expressions and equations that have rational expressions. This is a rational expression 6 over z minus 2, and this is a rational expression 3 over 3 times z minus 2. The problem for us is to solve this equation. Find the value of z that makes a true sentence. The first step in solving an equation that has rational expressions is to identify the numbers that would make a 0 in the denominator. You can see that if z is 2, I would have 2 minus 2, or 0, in this denominator. There would also be a 0 in this denominator. So the thing to do is to eliminate 2. So we're going to say right at the beginning that z cannot equal 2. The next step is to clear the fractions by multiplying by the least common denominator. Least common denominator is 3 times z minus 2. So you have to imagine multiplying that times each term. Times this term, the z minus 2 cancels, and 3 times 6 would be left over. Times this term, 3 times z minus 2 cancels, and the 3 is left over. Multiplying it times this term, the 3's cancel, and I have 14 times z minus 2. Z minus 2 is left over. At that point, we can multiply 3 times 6 and get 18. So 18 plus 3, and on this side, multiply the 14 through using the distributive property. You get 14z minus 28. Combining like terms, adding the 18 and the 3, bringing this 28 over and adding it to the result, I have 49 equals 14z. Finally, dividing by 14 and reducing, z is equal to 7/2. So the solution to this equation, the number that would make a true sentence, is z equals 7/2. The last chapter is about solving systems of equations. We will solve systems of equations by the addition method, by the substitution method, and also by the graphical method. In this chapter, we're working with systems of equations. We're given the system 3x equals 21 minus 5y and minus 4x plus 3y equals 1. We're thinking of this as a system of equations, and we're trying to find the solution to this system. We're trying to find the ordered pair that makes both of these sentences true. So that's the problem. Solve the system of equations. We're going to solve this system of equations by using the addition method. The first thing to do would be to move this term minus 5y over to the left. That would give me 3x plus 5y equals 21. The second equation is left as it is. At this point, we will look at the problem and try to determine which variable would be the easiest one to eliminate. We can eliminate the x's if both of these numbers are 12. And multiplying the top equation by 4 and the bottom equation by 3 would achieve that result. Both numbers would be 12. So that's what I'm going to do. I'm going to multiply 4 times this equation. That gives me 12x plus 20y equals 84. And multiply 3 times this equation. Minus 12x plus 9y equals 3. Then, when we add the two equations together, the x terms cancel out. 20y and 9y would be 29y. 84 and 3 would be 87. Finally, dividing by 29 just happens to go in an even number of times, and so y is equal to 3. To find the x value, we can substitute 3 back into one of the equations. We chose to put it right here, in which case 3x plus 15 would equal 21. That gives me this line. And then subtracting 15 from both sides and dividing by 3, I can find that x equals 2. So the solution to this system of equations, or the point of intersection of these two lines, is the ordered pair 2, 3.